Okay, today I will be talking about how to implement queue using two stacks, right? Using two stacks. This problem, in this problem, we will be using two stacks, which basically follows LIFO pattern. This LIFO pattern, right? LIFO pattern, last in, first out, and using the LIFO method or two stacks, we will be implementing queue first in first out. Okay, first in first out. Here queue, what we have to build is queue that supports and have all these operations such as pop, push, pick, empty, right? These operations should be in the queue that we are building. And the stack properties, the all the operations like push and pop from the top, right? And what is at the top element, what is the top element in the stack, right? Size, empty, this must be used in the two stacks for building queue. And if a stack is not supported in the programming language, like I'll be using JavaScript. Here stack is supported. If you are using any other programming language, if stack is not supported, you can use linked list, right? Or double indent queue, as long as following the standard operations of stack. Okay, this post pop from from top, what is at the top element, what is at the top of the stack, what is the size of the stack. This must be like these operations should be followed. So let's see first how queue works. Okay, how queue works, let's see first. I'll build a queue. Suppose this is a queue. Mm, 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 mm. This is a queue, and this is a front part, and this is the back of the queue. Okay, we push we push element from the back, and element is popped out. If we have to remove any element, we have to pop the element from the front, isn't it? Out, this is out, this is in, or aid, or push, pop. Okay, this is how we do. Suppose 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 we have these methods. I will just grab this. Don't want to I want to grab this. Okay, suppose see, we have to these are the methods we have to implement in the queue. If we have to do push of one, if we have to do push of one, then it will we will push one from the back of the queue, and one will be here, right? One will be here. One, two, two, three, four. Okay, so one, two, three, four. One, two, three, four. Now pop comes in. The pop method, what it does is it removes one element from the front. It removes one element from the front. It returns one, right? It returns one. Again, push. What it does is it pushes five from the back, and Q looks like this. Okay, and where we are, and then again pop will remove this element 2. It returns 2. Okay, it returns 2. And again push 6. push 6. Element 6 will be added from the back and q will be like so. Now we have to get the top. Actually in q there is no top, but it's a pick. Okay, and the pick, oh my god, sorry, then pick will return what? The front element. Pick will return this front element, these three. Okay, this three. Q dot pick, meaning this will return 3. Is it empty? Is the queue empty? There are 4 elements, right? So it's not empty. It would return false. False. Now we have to build this. We have to build this using what? 2 stacks. Using 2 stacks. Okay, using 2 stacks. So let's build 2 stacks here. This is stack 1. Just copy this. This is stack 2. This is stack 2. This is stack 1, which is a main stack. This is stack 2, which is helper stack. Okay, which is helper stack. Which is helper stack. Now, how does the stack works? Is it follows LIFO method. LIFO method meaning every element we add is done from the top, right? And if we have to remove element, it should be done from the top. So this top, right, it basically has access to top. Even whether we have to add element or remove element, it should be done from the top. Suppose if we follow these methods, see these methods here. So how will it work in a stack? Right, let's do it. Suppose we push 1 in stack 1, right? Let's put 1 in stack 1. So 1 will be added. 1 will be added here. Okay, 1 will be added here. And then 2. It will be added from the top. It will stack like this. 2. Now 3. And then what do we have? 4. And what we have is 4, right? This is how push method works. It What push method is doing is basically pushing the element from the top and stacking one by one, right? Stacking one by one. LIFO, last in. This 4 is the element which is lastly added, and this is the first element to be out. Everything is done at the top level in stacks. Okay. Now we see pop. The pop in Q, we are building Q using these 2 stacks, right? We are building this Q We are building this queue using what? These stacks. Now, in stack, everything happens at the top level, right? Everything happens at the top level. So, if we do pop stack.pop, 4 will be removed. 4 will be removed. But what we have to do is we have to get 1. We have to remove 1. Meaning, we are building the queue. If we do pop in queue, 1 should be removed. That is what we have to build. So, stack 1 is not helping us to achieve that goal, right? Achieve this goal that we have to remove 1. So what we'll do is we'll get the help from stack 2. What we do is we transfer we migrate these all elements into stack 2 first. Let's do that. Migrate all the elements, all the young elements, right? Migrate. First, what we do here is I'll write the 1. Let me write here. Okay, 1. First, add all. Let me add here. Okay, first add all elements into main stack, which is stack 1. Which is stack 1, right? Stack 1. Then then since we cannot, since the stack 1 using since stack using stack while using stack 1, we cannot basically remove directly 1 from the stack. We have to get help from stack 2. So since we since have we don't have access to 1, which is to be removed, right? Removed in queue. Then it, since we don't have access to 1, which is supposed to be removed in queue, what we do is we migrate all young elements, whatever the elements of stack 1, elements of stack 1 to stack 2. Stack 2. This is the second step. Okay, in stack we don't have any access below, any access below the top limit. We only have access to this top limit, which is 4. If you have to remove it, 4. If you have to add any element, it should be done after top limit, 4, after 4. So we cannot get access to 1. So what we are doing here is we are adding all this. We are basically transferring these elements into stack 2. So how will stack 2 will look like is let me, oh, okay, stack, come on, why stack 2, let me put in blue. Now I'll get a pen. Let's transfer this. So 4 will come here. 4 first, 4 will come, then 3 will come, then 2 will come, then 1 will come. See, 1 is at the top. 1 is at the top level now. This is the top, right? This is the top. Now we can do my stack dot my basically stack 2 dot pop, and one will be removed. That is what we have to build, isn't it? That is what we have to build. That is what we have to build. That is what we are supposed to build, isn't it? All the elements are added from. That is what we are supposed to build.
Okay. Then after what we did, we migrate all n elements and then we pop pop to stack 2 and stack 2 dot pop pop to return to basically return the top element, which is that is that is front element in queue in queue that is front element in queue, right? All right. And now what we did all the push, we did all of this push, and we also did pop. Now what if there is one more pop? What if there is one more pop after pop? What if there is one more pop? One more pop. What if there is one more pop after first pop? What will happen? Okay, let's discuss that. Since all these elements, since all the elements are shifted to stack 2, right? Shifted to stack 2 here, and we have already removed first item or the top or the front element from the stack, and all these elements are in reverse, already in reverse order, right? These are already in reverse order. What we can do is we can simply pop 2 from the stack 2, while 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 stack 2 dot length is not empty, right? Stack 2, if I'll write this over here. uh, 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 Sorry, right? I'll write this over here. If 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 is if if another if if there is another pop method, if pop method repeats, if pop method repeats after after the first one repeats, right? If this is for pop method, this is for pop method, okay, this is for pop method. If pop method repeats, what we will be doing is, if pop method repeats, right? If pop method repeats, and and stack, and if pop method repeats and stack 2 dot length is not empty, is not empty, right? This stack is not, or there are items in stack 2, then we simply we 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 remove and if pop method repeats and stack 2 dot length is not empty, right? Not empty, and since elements are already in reverse order, what we can do is we can remove another top element from stack 2, right? Stack 2. And if uh, right, stack 2, how do I explain this? Okay, is not empty. If it's empty, we push the item. So what we did here is, at first I have to do this as well. These all items, what we did was, I'll show you. What we did over here was we completely shifted these items, right? Shifted this item. 1, 2, 3, 4. 4, 3, 2, 1. Isn't it? We shifted. We shifted these items from stack 1 to stack 2. At what time? While the stack 2 dot length was empty. While we can remove top element from stack 2. Can remove top element from stack 2. First add all elements we don't have access, we migrate to stack 2. At what condition? Stack 2 only when stack 2 stack 2 stack 2 dot length, right? Length is empty, is empty, is empty. And then do stack dot pop to return the top element. This is the step. Okay, so stack 2 dot length is empty, we migrate element, or we transfer element, or we push elements into stack 2. If stack 2, if there are elements in stack 2, then we can do pop operation in stack 2. Mm, mm. So what we did was, what we did here was, I will write here, we migrate, right? We migrate all these elements into while I want to write in this fashion. Just write, yeah, this one. While stack 2 dot length is, while stack 2 dot length is empty. This is the condition here. Here we go. Push push or or migrate all push or migrate all n elements into stack 2, right? This is what we did. Now pop, what? Sorry, it's empty, right? Sorry. If stack dot length is zero, right? This was the condition. Sorry. If stack 2 length, if there is no elements inside stack 2, then only we can do push or migrate. If stack 2 length is not empty, fuck, sorry, is, what is it? Is not empty, is not empty. This is for this one. Is not empty, then do continue pop, right? All right, save it. Okay, where were we? Let's just remove this. Add all elements. We will be adding all elements into main stack 1 over here, and this is a pop part. Okay, this is a pop. Sorry, this. Okay, add cancel. So this part is for pop. Okay, when pop method is called, I mean pop method will happen where in stack 2. Okay, this over here will push all the elements from stack 1. If stack 2 is empty, we will push all the elements from stack 1 to stack 2. Okay, stack 2. When the pop method is called, because this is in reverse order, right? 1 2 3 4 reverse order, and we need to pop one, so what we'll do is we'll migrate all elements from stack 1 to stack 2, and over here we'll get the proper order for q, right? We'll get proper order for q. When we pop, one will be popped out, which exactly behaves as a queue. It behaves as a queue operation, right? One will be popped out, and then again pop, when the pop method is called, it checks if the stack 2, is it empty? No, then it will pop out. Okay, it will pop out 2 from the, this will also be popped out. Okay, this will pops out 2. Okay, this will pops out 2. Now this is for popping part. First see, this is in reverse, right? This is in reverse order, right? Reverse order, and this here is a proper, I mean proper order for queue, right? Proper order for queue, right? This proper order for queue. 1, 2, 3, 4. Now 2 will be popped out. Again, push comes in. Now this interesting part is over here. Push comes in. What we will be doing here is all the push part, right? All the push part, we will, whenever the push method comes in, we will add all the elements into stack 1. We will add all the elements into stack 1. So, so what will happen? This suppose let's consider this is again new stack from starting from here. So whenever the push comes in, what we'll do is we will push 5 over here. We will push 5 over here. Okay, new push. Okay, new push will again add an element. Add this 5 into stack 1, right? Stack 1. Then this what we have done this one is done, this one is done, this one is done. Pop, we have popped out all the pop. Whenever the pop method is whenever the pop method is needs to be called, what happens is if stack 2 is not empty, then pop methods executes over here. It removes elements from the top which exactly behaves as a queue, right? Because the elements will be in proper order for queue. One will be removed, and then once again 2 will be removed. When the push method comes in, when the push method needs to be executed, we add elements in stack 1, right? Stack 1. So add. Now again pop comes in. When for this method, what happens is, right? I will write it over here. For this part, what happens is what happens is what happens is first, right? First checks if stack 2 if stack 2 is not empty, is not empty, then remove top element. Top element, right? Remove top element, which is front element in queue. Front element in queue. Okay, front element in queue. This is what front element in queue. All right, front element in queue. All right, now what will be popped? Now it checks, is stack 2 empty? No, there are elements. So from here 3 will be popped out. 3 will be popped out. 3 will be popped out. Now again push method comes in, right? Push method comes in. Again push method comes in. What we do? What happens when the push method comes in? element 6, element 6, sorry, element 6 is added in stack 1. 6 is added in stack 1. Now this one is also done, right? Push this one, done, 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 right? And done, done, done. Now pick. I think I have added pop, so I made a mistake over here. Now see, pick exactly. What happens is, okay, okay, pick exactly behaves like pop, pop. Okay, pick exactly behaves like a pop. Now see, exactly behaves like a pop means the front element will be 8, what? Stack 2. Now see, top element, right? Top element. We pick means return the front element, which is the first of the queue. That is, now see what happens is, whenever the pick method comes in, it will check if the stack 2 is empty or not, right? Empty or not. It's not empty. There is 4, right? There is only one element left, which is 4. That is the front element. That will be the front element. Now see, that will be the front element. I'll change the color to this, and actually not that, maybe this. Okay, this. Okay, cool, right? Now see, this one is the 4 is the 4 is the front or top element, right? Top element. What is this? Front element. Front element. So 4 will be returned as a front element when the pick method comes in, call, or for pick method is invoked. Now we need to return 4. That. What else? What else? Now, if now see if there was a pop method, what happens is, for if there was a pop method after this push 6, if there was a pop method, 4 will be removed. 4 is supposed to be removed. 4 will be removed from the stack 2, and stack 2 will be empty. Now, after that, if pick method was there, then what it would be like is, we have to basically migrate all these elements from stack 1 to stack 2. Okay, suppose what I want to say is, after this, right? After this, mm, 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 mm. After this, right? For order for q. Okay, yeah, that's fine, right? That's fine. Now, after this, if there was, right, there was a pop, there was pop, right? There was pop, right? This will come here, right? This will come here. This will come here. So, if there was a pop, this pop method will, so see, this will return 4. right? This will return 4. This will return 4, right? This will basically return, yes, 4, 4, right? This will return 4, and this will be empty. If I if there was a pop, if there is a pop method after this pick, 4 would be removed. 4 would be removed. So it would be empty. Now, now if now if now at last for empty, at last for empty function, what we'll do is we'll check both the stacks, if both the stacks are empty or not. If not, we'll return false. If both of the stacks are empty, then we will return true. So since there are two elements in stack 1, our empty function will return false here, right? That is what we are supposed to do. Let's do more, right? Let's do more. What if, right? What if there is a pop after this? Okay, let's make it more, right? Let's make it more interesting. Let's make it more interesting. Now, pop comes after checking empty. This will return false. And right, this will return false, isn't it? This will return false. Now again, pop function comes in. Now, when the pop function comes in, what we will be doing is we check we check in the stack too if there are elements or not. If there are elements, we'll pop them out. If not, if there is the stack is empty, right? If the stack is empty, we push, we migrate, right? We migrate these elements 5 and 6. First 6 will come. Okay, okay. 1 second. Sorry. What we'll do is, well, I'll take this here, and basically I will increase this, and I will mm, 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 mm. Right? Okay. Now what will happen? This is after this one. So we have done this as well. This as well. We have done this as well. We have done this as well, right? Maybe it's making more rough. I'll erase this. Oh my god, this. Okay. And now see what will happen. This 5 will come over here. Sorry, first 6 will be migrated, right? 6 will be migrated, right? 6 will come over here. Basically, yeah, 6 will come over here. Uh, 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 uh. 6 will come over here, right? And then 5 will be migrated. All elements will be migrated. So 5 will be down, 5 will be here, right? 5 will be here. So when pop method comes in first, First, this 5 will be out. 5 will be out. And then after that, it checks 6 will be out. 6 will be out, right? 6 will be out. Now 6 will be out, right? 6 will be out. And then now at this point, if we check, right? Now, see, Control B, Control C, Control B. Now if we check after this, now if we check, now if we check after this, what I'll do is, and now if I check, now if I check empty, right, empty, it will return us true, my friend. It will return us true, true. Wow, this was so much. Both stacks are empty, right? Both stacks are empty now. So when you check the empty, it will return us true from here. Okay, so if the stack 2, if stack, so first we push all the elements in stack 1. Okay, we push all the elements in stack 1, right? We push all the element in stack 1. This is in reverse order, isn't it? This is in reverse order. Reverse order. If the if we have to remove, we have to we have to we have to we have to basically we have to make it in proper order for queue, because we cannot directly access it, access one from stack 1, so we have to reverse again. So if the stack 2 is empty, we what we do, we push all the elements from stack 1 to stack 2. One will be at the top. When the pop method calls, it checks if the stack 2 is empty or not. If it is not empty, if it is not empty, I made a mistake here. Here it should be here. If stack 2, if the stack 2 is not empty, it will pop out 1 first, right? It will pop out 1 first, then it will pop out 2 because it's not empty. 2 after that. When push method comes in, the push method happens in stack 1. Okay, we make a push method in stack 1. We push all the new elements in stack 1. Again, pop method is here. It checks again if the stack 2 is empty or not. It's not empty. It will pop out 3 from the stack 2. Again, the push method for push method. This push method for push over here, for push method again, 6 will be added. 6 will be added in stack 1. Okay, 6 will be added in stack 1. This is done. Now pick exactly behaves like a pop. Okay, a pick exactly behaves like a pop. We don't have to do anything. Whatever is the top, whatever there is at the top of the stack 2, that is the top element or front element. And so at this point, 4 is at the front, or 4 is the only element in stack 2, so 4 will be the front element. Pick is done, 4 will be returned. For Again, pop method, it checks if stack 2 is empty or not. It's not. That is 4. 4 will be popped out. 4 will be returned. 4 will be removed from the stack 2. Now stack 2 is empty. Right? Stack 2 is empty. It checks for empty, empty. Now empty function. It checks if both the stacks are empty or not. Stack 1 is not empty. It returns false. Now pop method comes in. For pop method, it checks first if stack 2 is empty or not. If it's empty, it will it if stack 2 is empty, we will transfer or migrate all the elements from stack 1, right? All the elements from stack 1 to stack 2. It will be in 5 6 this order, proper order for q. First 5 will be popped out, then 6 will be popped out. Now for the empty function, it will check if the stack 1 and stack 2 is empty or not. Both the stacks are empty, then we return true from the function. This is how we implement queue using two stacks. Using two stacks. All right. Let's write code for our problem. Okay. First we will create stack one. This dot stack one, and we create stack two. Stack two. Right, for stack 2, and then we'll push all the this dot stack 1, we push all the x stack 1 dot, I think we can do auto stack 1 dot push all the x into stack 1, right? And then now for pop, what we have to do is for pop, you see, for pop, I cannot just directly remove the top element from stack 1 because it's in reverse order, right? I need to migrate or push elements from stack 1 to stack 2, isn't it? Yes. So I was fixing my screen. Okay. So now for pop, what we have to do is see. Yeah, it's properly visible. Okay. For pop, what you have to do is we cannot directly pop this, right? Cannot directly pop one, right? We have to pop this one. We cannot directly do remove one from stack. So we need to migrate. We need to push. We need to get help from stack two. So what I'll do is, okay. So if this dot stack two dot length is equals to 0, then what I have to do, I have to push element from stack 1 to stack 2. Okay, stack 1 to stack 2. So I have to push while stack 1 dot length exists. If it's not 0, if there is an element in stack 1, what I have to do is let let let, or uh, let's do this dot stack 2 dot push this dot stack 1 dot pop, right? This will basically pop the element from the top, and it will push into stack 2. It will push into stack 2, and there will be stack, right? And if there is item, if there is already item in stack 2, then just pop the item. This dot stack 2 dot pop, right? We have to do this case, right? If there is item, just pop the first item. if the stack 2 length is empty, just transfer all the elements from stack 1 to stack 2, right? Stack 2, and then we'll get the item, and then we'll pop the item from stack 2, isn't it? Stack 2. Is it visible? Yes. Is it okay? Let's do pick part. For pick part, what we have to do is pick. We have to get the front element of the queue, right? Whatever is the element is at the front, that is the element we need to remove. Sorry, not remove, we need to return. So it actually behaves like a pop, and we have to, okay, let's do here code. Let's go to code. So if this dot is stack 2 dot length is 0, if it is 0, then while we have to transfer all the element stack 1 dot length, and this dot stack 2 dot push stack 2 dot push is this dot stack 1 dot pop. We pop from stack 1 and push into stack 2, right? We push into stack 2, and what we return is this dot stack 2 stack 2 stack 2, and we basically return this dot stack 2 dot length minus 1 we'll get the front element, or yeah, we'll get the front element, right? We'll get the front element. So similarly for empty, if stack this dot stack 1 dot length is equals to 0, right? And this dot stack 2 dot length is 0, right? Then return true, else false, if else false. Oh, okay. This dot what else? This dot. Ooh, I made a mistake. What did I do? It's coming undefined. What happened? Output is undefined, else return false. Okay, this is else part. Let's submit. Stack 1. Where? Line number 20. Okay, here is it. This dot, right? Okay, it works. Yes. That's it. In this video, I have solved this problem where we implemented queue using two stacks, right?